Well, I'm very excited to be here and present, and I'm the curation lead, so I'm going to talk about what the differences are between the collection curator and the curation lead a little bit. So if we go to the next slide, I want to talk a little bit about the goals and importance of lunar curation and Artemis curation specifically. We all know how incredibly important curation has been for Apollo, the gift that keeps on giving, because these samples have been so carefully and meticulously curated. For Artemis going forward, the goal is equally critical to preserve the samples from the time of the collection on the lunar surface all the way to their return to Earth and then arrival in that curation facility, while we are ensuring the sample integrity at all stages of the mission. So with their arrival here, we will then carry out the initial sample characterization and developing the preliminary catalog, which means providing enough information so that you guys in the lunar community can select the best possible sample to address and carry out the best possible science in your respective fields. And then ultimately, curation is all about long-term curation, protecting and meticulously documenting what happens to the samples at all stages, and then allocating the future Artemis samples and the current Apollo samples so that scientific investigations can continue to be carried out, and therefore that the legacy of the astronauts who have and will in the future collect these amazing samples. So not all of this is the responsibility of the curation lead, because that's a lot of work. And so this will be a shared responsibility with the Artemis collection curator. And so to highlight the difference between the tools, if we go to the next slide, I'll highlight this a little bit. So curation and the responsibility of the curation lead starts long before we return the samples from really any planetary body, be it the moon or an asteroid or Mars. Curation starts with the pre-mission planning phase that includes ensuring that the environmental conditions are met at the Earth facility, which is here in Houston, where we will store the samples, ensure the integrity, and to make sure that we are ready to receive the samples. The curation lead will also support the active mission during sample collection on the lunar surface, which means helping to think and facilitate through methods how to collect the samples, monitor and record any potential contamination or degradation, storage and transport condition for samples that are collected on the surface, and then during all the transfer points until they arrive here in Houston in the curation facility. And then helping to think and facilitate the timeline, procedures, and risk mitigations during these transfer points from the start of the collection on the lunar surface all the way to their arrival here. Now, this is a huge group effort. Obviously, I'm not doing this by myself. And so that's why the curation lead is part of the Artemis internal science team and the sample sub-team specifically within that group, which also includes Dr. Barbara Cohn and Dr. Andrew Needham. And so this is an amazing team that has a lot of sample experience and expertise on sample integrity and contamination knowledge. And so that will ensure that we're not going to miss anything and that we can represent the samples in that mission from the point of view of the samples to other stakeholders, like flight directors or the astronaut office and the various vendors who are providing storage places, including sample canisters. So we're basically the voice of the samples. Now, once the samples arrive back at JSC, the curation lead will then work with and co-lead the preliminary examination with the Artemis collection curator. So we go to the next slide. After PE is done, the initial preliminary sample catalog is publicly released. The curation lead then moves on to plan the next Artemis mission, and then the whole cycle starts over, which is not really that easy since the whole planning for the next missions has already started while we're still working on Artemis 3, and so there's a lot of overlap. And because that is a lot of work, next slide, we will have an Artemis collection curator in addition to the Artemis curation lead. And so the Artemis collection curator will then take over and take care of the already returned Artemis samples, so Artemis 3 samples, and then plan for long-term curation, which includes everything from protection to preservation to allocation of these samples. Next slide. So for Artemis 3 sample return, we will collect samples from a different region on the moon compared to Apollo, which is the southern polar region. Artemis 3 currently will return ambient samples, and future missions might include cold sample return. And for that, the Artemis curation lead will then work together with the future cold curation lead and help define conditions for the return of and the curation of these cold samples. Now for Artemis 3, they will be stored and processed and curated under room temperature in the Apollo lab under the direction of the Apollo sample curator, which is Ryan Ziegler. Next slide. So here are some images of what the current pristine facility looks like. That you can see on the right. There is enough space to accommodate the Artemis 3 samples without compromising the existing Apollo samples. And we are also preparing for the additional workload so there will be enough, so that there won't be any cutbacks to processing of the existing sample collection while we are also processing the newly returned samples. So similar to Apollo, the Artemis samples will be kept in this ISO 6 clean room. They will be stored in dry nitrogen gas, which is a gas that really doesn't want to interact with anything, so that's great. They will be kept in stainless steel containers in stainless steel cabinets in the lab and in the vault, so that we can keep them pristine. Similar to Apollo, for Artemis, the only limited materials that are allowed to come in contact with the samples are stainless steel, aluminum, and Teflon, and that will ensure that future scientific studies can be carried out. Keeping in mind that technology will evolve and future instruments could and probably want to measure and detect other trace amount of elements that we haven't even thought about using to answer current scientific questions. And that's why we're limiting the materials so much and we're so strict about it. Then all these samples have a handling history. So we know exactly what happens to them, which environment they experienced. And that history includes anything that happened to the samples in transit, in the lab, and while they are with the PIs. Next slide. So where are we currently with planning? We are working on the different curation plans, which includes a PE plan, a curation plan, and a strategy plan. We're also working and just finished the initial sampling concept of operations, so-called CONOPS, which ensures the sample integrity from the start of the mission prior to sample collection all the way to the end, which basically marks the sample transfer into the glove boxes at JSC in the curation facility. So this is a schematic sketch that you can see of what is involved in the Artemis 3 CONOPS at the moment. This is an integrated multiple stakeholder process that involves all the different people that are part of the surface planning effort. And so this is an evolving process and might change or will most likely change as the mission evolves and matures. So this is not written in stone. Don't get hung up on this. But overall, just to run through really quickly, the first steps include planning, developing, and ground testing of procedures and tools, manufacturing, which includes cleaning of tools that are needed for sampling, training the crew on all these processes, transfer and delivery of sample hardware. For the geology tools, that includes witness coupons and plates for contamination knowledge. It includes inspection, storage, and ultimately integration of the sampling hardware into different vehicles at different stages, so that we can ensure delivery of the sampling hardware to the lunar surface in a pristine state. Then we have thought through launch, transit, and rendezvous transfer points, often between different vehicles, and then landing and the delivery of the hardware to the surface, so that we can really ensure sample integrity. Now, the surface activities include a whole slew of processes that range from thinking through preparation needed prior to a first EVA and collection of the initial sample, payload deployments, overall sample collection and procedures and needs for the different sample types, all the documentation activities throughout the EVAs, tools and sample storage, and so on. And then finally weighing the samples in stowage location during launch, transit, and transfer throughout the entire journey. So that also then includes all the way the initial recovery after splashdown from Orion, a potential temporary curation facility on the recovery vessel, and then the transfer to the curation facility here in Houston. So this is a big document. It includes 58 points of contact of people who have helped us draft this all across all the NASA centers and within all the different divisions and different programs that are involved in these surface planning efforts. And so this is going to serve as a baseline, and we are currently working on the broader CONOPS that includes LTV and PR. Next slide. So this is just a summary. We're really running fast and hard, and the curation labs are in the process of getting ready to receive the Artemis 3 samples that are returned under ambient temperatures. We're working on the curation strategy plans, the overall curation plan, and the collection plan. The ConOps for Artemis 3 has been a huge team effort and has been developed. The broader context for ConOps is currently underway. And this is providing an integrated strategy to protect the samples, ensure their integrity, and therefore really maximize their scientific return. So this document includes a lot of people and will evolve and be updated accordingly as the mission matures. And, that just means lunar science future is bright and fun and exciting, and we're going, and I can't wait to get there. So I think this is my last slide. Thank you for your attention.